All right, we're working with vectors still a little bit today, but today and tomorrow included, we're going to take a couple of days with this because it does kind of take some time to let that sink in. It does take a little bit of work. What we're going to focus on today is just more so the direction. How do we describe the direction of a vector? And more so, how do we describe that when we're navigating, right? This is another area I know I talked about yesterday that we use forces to talk about vectors, or sorry, backwards. We actually use vectors to describe forces. But we can also use vectors in navigation when people are flying or, um, on boats, things like that, sailing around. You use vectors to describe where we're going, right? That's often a way to kind of put that. And so our mathematical terms for how we describe angles and navigation terms for how the angles are described are different, right? They're different than a standard form where we say, hey, we start on the x-axis and we go around counterclockwise. That's the standard mathematical notation. However, in navigation, it's a little bit different. So that's what we're going to start with today is what are those differences and how do we describe those two things? We're going to talk about two main ones here today. And that's going to be your heading and your bearing. They have very similar meanings, but they're slightly different. And sometimes when I'm talking or when I'm going over stuff, I switch the two around a lot. But I'm going to try and describe to you what the difference between those are. So the first one, your heading, you actually only need one object to describe something's heading. Okay, so something's heading is measured from north. Okay, so here this plane would be described to have a heading of 0 degrees because it's pointed north. And we measure that from north. So it's if you have a heading of 0 degrees or a heading of 360 degrees would also still be heading straight north, right? Because you'd have spun around in a circle. And a heading of 90 degrees, we always measure headings clockwise, okay, which is a little different from how we do our standard angles. So here a heading of 90 degrees would actually turn this direction clockwise 90 degrees in that case. Now the nice thing is if you use like these Google Sheets to make to turn your stuff, Google Sheets actually works, in headings. So notice there's this blue dot up here. I can grab that, click on it, and use it to turn the whole image, and it will kind of tell me what angle it's at, and it always measures 0 is straight up and down. And then as I turn this way, we can see the angle increase. And once we get to 90 degrees, now this airplane has a heading of 90 degrees, which I'm going to make it a little bit smaller just so we can, so it fits in that box. But this one has a heading of 90 degrees. If we wanted a heading of 270 degrees, same thing. It would spin here's 90, here's 180. 180 would be a heading of 180 is actually straight south. So a heading of 270, which I'm going to hold down the shift button because then it just jumps up every few degrees and let go. That would be due west, right? A heading of 270 is the same as due west. And so then 136 degrees here, if I wanted that heading, I would start here. Here's 90 degrees, here's 180, so it's got to be somewhere in between 190 and 180. And since I'm using this computer program, I can actually find out pretty close to exactly, likes to kind of stick on that 135. So I'm going to put it there and say that's pretty close to 136 degrees. This has a heading of 136. So that's what heading is. You just measure that object. What direction is that object facing, in essence, right? That's a heading. On the other hand, bearing, you need two objects to find bearing. And that is you're measuring of let me see if I can say this right. Bearing is you are measuring the heading to the vector or to the thing connecting the two objects. It's a lot of words to say at once, so let's take a look at the picture. So what I have drawn here, or pictured here, is two airplanes. One airplane here has a heading of 51.7 degrees. This airplane has a heading of 321.5 degrees. That's its heading, and it's not its bearing. To find its bearing, what we need to do first is to connect the two objects, right? We need to have a connection between the two, kind of like, okay, this one, though it's flying this way, the pilot could turn his head and look over here. And this pilot could turn his head and look this way. So I'm gonna, make this one a little bit thicker, and we'll make it blue for bearing. So make this a nice blue color. That's for its bearing. And now the bearing between these two would be measured, and you have to say from which plane. Okay, so the bearing from kind of the blue plane to the blank plane, I guess we'll call this one a blank one. So from blue plane to blank plane would be to measure from due north to this line. So what I mean by that, I'm going to take a curve, I'm going to stick this in here, this spot, double click to end, put an arrow on it so we know what direction we're going, and make it blue, make it nice and thick. This is the bearing, okay? So let's type, I'm going to type that in there. This would be the bearing from, we'll call it the teal plane to the blank plane, whatever we want to call that, okay? So that is the bearing in there. And whatever this measurement would be, that would be the bearing from this plane to this plane, okay? If I wanted to find the bearing from the blank plane to the teal plane, that would be over here. I'd start at due north and make this, I'm going to start up here, I'd check what's the angle from due north over to this one. So here again, oops, let's make this go the other way. So we're measuring down here. Again, I will make this blue. I'll make it a little thicker so we can see that. And so this now is over here. This is the bearing from so it's a little bit different. This is the bearing from the blank plane to the teal plane. So it is a little bit different on here when we talk about bearing. You need two objects and you need to measure from one to the other. So the order is important when you're talking about bearing, because obviously the blue angle up here is much larger than the blue angle down here. We can see this one is acute and this one is obtuse. And now in here, I'd love to go through and I'll say, hey, yeah, we can find the angle in here. And we can't because I didn't put any distances between here. To find a bearing, you often need to know how far apart the planes are, or how far they have flown. You need some type of distance to help you figure it out because of, we need to either use the law of sines or the law of cosines in order to do that. So that's where we go in here. That's how we get the bearing of the plane is from one object to another. Okay, so I'm going to do one full example in here, and then you guys just have a couple of questions for your homework today to kind of set those up. And then tomorrow we'll have a few more to continue working with that, because it does get, some of these pictures do get a little bit intenser. You got to put a lot of little pieces together to put that in. Okay, but that's the difference between bearing and heading. So we'll look at an example with a few different types of things in here. I tried to put a few things in here. So here a plane flew from, I'm just going to call them point A, point B, point C. Obviously, when you're navigating, you'd go from city to city. But to simplify things, we're just going to work with these points here. So here we're going to start at some point A. I'll just put an A in. Oops, let's make that capitalized so it. There we go. Now my caps lock button works. So we're just going to go from here, and I'll put some bars around it so we can see that. So we're going to go from A to B, then to C. So it's going in, it's moving here for 100 miles, then it's turning and going to its final destination. So how do we read some of these pieces? So in this one, it says south 30 degrees east. It's just a different way to represent something's heading or what direction it's going to go. So if you don't have an angle with, or you don't have directions placed with it, such as this second one, what we were talking about, that's always from due north, and then you go clockwise around there. But if we have some directions, we can use that to indicate how it's moving here. So this one says south 30 degrees to the east. And so what that means, let's take a line here. It means we could look straight south. That's kind of our first point. And then we're going to turn 30 degrees towards the east, which east is over here. So we start by looking south. We're going to turn 30 degrees to the east, and it's going to go 100 miles this direction. So that's where here I'm just going to take this, and we would say, yep, it would start south, but it's going to turn 30 degrees to the east, go about 100 miles this direction, somewhere down here, right? I don't have a scale set up. So this is its second point. I'm going to call that B. So that's where it went from here to here. Let's connect another line from A over to B. Okay. And that has to be in here, about a 30 degrees in that case. All right. Well, let's put that in there. And then I'm going to make it look a little bit more like a 30-degree angle because that looks about 45. So I'm just going to pull that in. So there's about 30 degrees. That's south, and then 30 degrees towards the east. That's what this one is. And the next one says we turned to a heading of 43 and went for 60 miles to destination C. So I'm going to grab this one. Again, heading is from due north and then turn clockwise. So it would be looking this way and turn 43 degrees, in this case, towards the east. This would be the same as saying north, 43 degrees east, right? It'd be the exact same thing, but we don't have to always put that there. So here it'd be the north and then 43 degrees to the east, and it went about 60 miles this way. And I'm just going to place it there. You know, I don't have any scale on this thing. And there it ended up at C. So to reiterate that, we started by looking straight north, and then we go ahead and take this and say, okay, connect from B to C. Oops. Let's actually draw a new one in there. Oh, yeah, I did draw a new one. Okay. So on here then, this amount in here has to be 43 degrees, right? That's what we know in that case. And then our last piece that we want to know is what is the bearing from A to C. Okay, from A to C, I want to know what is it if I measured from due north down to this line, which the way I've kind of set it up, it looks like it should be an obtuse angle. It should be something bigger than 180 degrees. And let's make this line blue so we know that's the bearing that we're looking for. From A over to C, I want to measure what's the angle down to this blue line. All right. So in here, now we just need to fill in some pieces. I know a little bit that this was, 100 miles. So I'm going to take that one and maybe put this one in here nice and carefully. And we also know that over here, that it went 60 miles over here. I can turn that in a little bit. Oh, turn that guy. So there's 100, there's 60, and we might need to know some other pieces, right? I want to know what this little angle up here is, right? That's a little bit of a problem area. Well, because if we can figure out this angle, well, then we just take, 30 and that one, subtract it from 180, and that'll give us this top angle up there. Let's see if I can extend this line up a little bit. Okay, this is the angle we're looking for up top. Well, some pieces we know. This is straight up and down, north to south line. Here's a north to south line. So if this is 30 degrees, this angle in here must be also 30 degrees. So I could fill that in. I'm going to take this and say, all right, I'm going to move this one over and say, oh, yep, that's got to be 30 degrees as well. Let's color that red because we figured that one out. Yeah, that's something we figured out in there. And then it's like, well, this whole thing is then 73 degrees. We could say, well, can we figure out any other pieces? What I really want is this angle up here, but I only have a couple of angles within here to work with. So we'd have to do this in 2 steps. Number 1, I could figure out the length of this blue line. In other words, I could figure out its magnitude, right? Which we're not being asked to find, but we'll need to use that to get there. So to find this, we would use the law of cosines. I could say this is C squared here, or let's say B squared, because that's across from B. And here's my C, here's A, and we could figure out the length of this line. So that's exactly what I'm going to do here. So I'm just going to set that up in here. Okay? So we have that B, oops, let's use a lowercase b. They're finding a side. So our 2 sides were 100 squared plus 60 squared. And then we would do minus 2 times, type that in right, oops, I need to double check what that angle was. This angle was 73 degrees, so cosine of 73 degrees. Okay. So that would be the whole thing, right? We could type this entire piece into our calculator. So I'm just going to grab mine and click run through that. So we've got 100 squared plus 60 squared minus 2 times 100 times 60 times cosine of 73. Make sure I'm in degree mode, and I hit enter, and that is quite a big number here. So I know in this case, let's see if we can get off that. Oh, quit putting new stuff in there for me. I don't want cosine, I want 73 in here. Love this computer program right now. Stop that. Oh, whatever. Yep. Nope. Okay, well, let's just insert the math then. I thought I could do this all at once. So let's just get rid of that. And so that is 10,091.54, something like that. That's what that is. So then to finish solving that, we could take the square root of that. Square root of 10,091.54, which is, it's not going to work out perfectly. So let's take the square root of that stuff. It's about 100.46. 100.46 miles. So that, I know my little bit of work here. So I'm going to put this, maybe make it a little smaller. Let's put all this stuff together up here. It's kind of freaking out a little bit, isn't it? All right. So there's kind of our work for finding that side, side B, right? Okay. So that means this top side up here, let's grab one of these, has got to be 100.46, right? So that's what I'm going to put in here, 100.46. And then the next piece here, and say again, we're trying to find this top angle. So if I find this little one at the bottom, we could take that all the way from 180 and be done there. So in this case, now I'm going to use the law of sines to figure out what this little angle is, because now I have a side and the angle across from it, 60 is across from this one. So that would be my next setup, right? My setup number 2. So let me grab everything here and we'll get rid of it. So in this case here, we want to know what that is. So we've got a sine of A over 60, because they're across from each other. And then we also have the one we just found, well, sine of 73 over, oh, it does let me do it this time, 100.46. That's kind of what we have in our step 2. So I'm going to put this one a little bit lower, because now we're doing this after we figured this one out, right? We figured that out. So again, this is across from our 73-degree angle. A is across from 60, and then we just solve this. You know, cross multiply, whatever, 60 is on the denominator, so I'll multiply that over. So in this case here, 60 is on that denominator. I would multiply it over here, okay? And then I would just, let's just grab our calculator, and I'm just going to type that whole thing in. Let's go sine 73 over 100.46 times 60. And yeah, we get about our 0.57, yada, 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 0.5711. And we have that. And so then in order to work this out, we would do the inverse to find that angle. So I would use my sine inverse of 0.5711. 0 in front there so we can see that. And that's what that angle is going to be. So we use our inverse to finally find that angle, which again, now I'd go back to my calculator and do that, which says that's about a 34.83 degree angle. Okay. Let's put that. All right. So put that in there, right? So there's my work there. I know it's getting a little crowded in here. I'll make sure to, move those things out for you a little bit and get rid of some of that. So I'll reposition it so when you guys look at the notes, it's a little more organized in how we find that. But that means we found out that this little tiny angle up here, so I'm going to move this up, is about 34.83 degrees. That's what that is right there. And we'll put that one in red because that's what we found there. And so that means we can finally find the bearing. Now all this complicated stuff is over with. We can finally find the last piece up here, because we can say, well, we would take 180 minus all those things. So 180 minus 30 and minus that 34.83. And we would know, oh, there's 115.17 degree angle in there. Okay. And so let's make this thing nice and blue or something like that, so that it matches our line, because that was the bearing that we were looking for on there. Okay, so that's our final answer in there. It takes a little bit of work. These questions are not like a one-step, one-time thing. You do have to work through these just a little bit to get there. We'll make it bold, and let's put that around there. But that would be that final result in there. That's the bearing from A to C, is this 115.17 degrees, and that's how we get there. So you might have to use a little bit of the law of sines, a little bit of the law of cosines, some inverse trig functions. So if you do have questions, if you do have questions on these, send me an email. I can try and work some of those out. And now I know on this stuff, I put everything on the computer to do it. I do not expect that you have to draw everything out and type it all on the computer. It is much easier to draw these out by hand. And I would suggest that. I know for me, it's a lot easier to take stuff and draw them by hand. So do that, take a picture and upload the picture. You certainly do not need to type everything into Google Slides. I know that can be a little bit tedious. You saw that as I was going through that. Draw by hand, take a picture, and upload that. It's a whole lot easier. So a couple of problems today, similar stuff tomorrow, just to continue kind of getting an idea. But again, send me your questions if you got them. Otherwise, good luck.